This video is about measuring angles. Okay, so an angle is the figure that's formed by two rays that share the same endpoint. So in this picture you see the ray CP and the ray CM, and when they meet at C, they form the angle called angle number 1. You can name an angle two ways, either by 3 letters in a very specific order. So this could be called angle PCM or angle MCP, noting that C has to be in the middle. The vertex point has to be in the middle. Or you can name an angle by a number, so angle 1. And that little symbol in front is the symbol for angle. The rays are the sides of the angle. So if you ever hear, name the sides of this angle, it's talking about the two rays. So the two sides of this angle are CP and CM. And the end point, the common end point that they share, is called the vertex of the angle. So the vertex of this angle is point C. We measure angles in degrees. That's one very common measurement for angles. It's the one we'll be using most of the year. So we measure angles in degrees. This angle is not drawn to scale. I have it labeled as 80 degrees, though that doesn't actually look like an 80-degree angle. You have to just go by what it says on the picture, so don't trust your eyes, trust the labeling. To show angle measure, we would write a lowercase m before the angle symbol. So m angle A, you would read this out loud as the measure of angle A. So when you're talking about the size or the measurement of an angle rather than just the name of the angle, you want to put that little m in front. So the measure of angle A equals 80 degrees. And in fact, this is not an 80-degree angle because we want to think about a 90-degree angle would look like this. So 80 degrees should only be slightly less than that, maybe more like here. But again, don't trust your eyes, just trust what it says in the picture. If it says 80 degrees, you go with it. To classify angles into different groupings, we have angles that are less than 90 degrees, which are called acute angles. These are good vocabulary words to know. We have angles that are exactly 90 degrees, and those are called right angles. And that's like the corner of a piece of paper, corner of a desk, and corner of a rectangle, 90 degrees. Obtuse angles are the ones that are greater than 90, but less than 180. So those are the ones that are like a door that's open wider than 90 degrees. And then a straight angle is an exactly 180-degree angle. It looks like a straight line because the two rays end up going in opposite directions from each other. And then there is such thing as an angle that's greater than 180, and that would be if one ray was going like this, and the other ray, went past 180 degrees, something like that, which is called a reflex angle, but that's not that important at this stage in the year. Two angles with the same measure are called congruent angles, just like congruent segments that we've talked about that are the same length. These are angles with the same degree measurement. They are indicated with these little arcs. A single arc, let me circle it in blue. So a single arc is going to be the same size as another angle with a single arc. So if I was to write the name of some congruent angles here, I could say that angle BAJ is congruent, which is an equal sign with a squiggly on top, to angle DFE. And notice I'm using 3 letters when I name each angle. So when I say BAJ, I'm talking about the angle that is formed when I start from B, go to A, and then end at J. So the angle that's formed in the center letter, the middle letter, or the vertex letter. So the angle at A. The reason I can't just call it A is because there's a bunch of angles right here at A. So you need to specify that you're talking about BAJ, so I know you mean the one up there on top, this angle right here. So that's congruent to DFE because those both have a single arc. Different measurement for angle CBJ because that has a double arc in it, and that's right here. But that would be congruent to angle. The other one with a double arc, which is FHG. And then the other pair that's congruent on here is the triple arc, and that would be BJA being congruent to, let's say, FJH. So those are 3 pairs of congruent angles that are shown on this picture. The angle addition postulate, which is a lot like the segment addition postulate, says if point M is in the interior of some angle, for example, PCN, and that's shown here. We have the point M that's somewhere inside of the angle PCN. Then the measure of angle PCM plus the measure of angle, let's say MCN. Establish where those two angles are for a second. So PCM is talking about this angle here, and MCN is talking about this angle here. And when you add those two together, it equals the measure of the entire angle. So measure of angle PCN. And hopefully that should be pretty obvious, right? Basically, when you add together angle 1 and angle 2 in this picture, it's going to equal the entire size of angle PCN. Let's see that with some algebra applications. So here's a picture of a basically a straight line along the bottom. That's angle DEF. Remember, if it looks like a straight line, it's a 180-degree angle. And it tells us that DEG is 145 degrees. I think it's helpful to label that on the picture. So there's 145. And it wants us to find GEF, which is the little angle over here. Since it's what I don't know, I can call it X. And then the equation I can write is, because I know of the angle addition postulate, when I add X plus the 145, it should equal the total angle DEF, which is a 180-degree angle. It's a very simple equation. Solve it by subtracting 145, and X equals 35 degrees. Slightly more complicated here. We've got an angle that's not a straight line, so 180 degrees is not going to enter into this equation anywhere. Instead, they have to tell us the measure of angle RQT right here, 155 degrees. So they have to tell us that the outer angle from R through Q all the way to T, that whole thing, is 155. And we can see from the picture the way it's labeled, when you add the two pieces together, so 4x minus 20 plus 3x plus 14, so add the two pieces together, and it should equal the total, which was given as 155. And then this is just a linear equation that we have to solve. I see some like terms to combine, 4x and 3x. I see a minus 20 and a plus 14. 7x. 7x equals, I've got to add 6 to the other side, so 161. And then divide both sides by 7. And x equals 23. This time I don't want to put degrees on that answer, because if you look at where x is right here, x is not a degree measurement, x is just a variable. The whole quantity 4x minus 20 has the degree symbol on it already, so you don't need to put an x, rather a degrees on your x, because there's already a degrees up there labeled in the picture. It wants me to then calculate the measure of the two angles, so RQS and TQS, I'm reading that in the question, by plugging in that value. So 4 parentheses 23 minus 20, this is my measure of angle RQS, and 4 times 23, 92, minus 20 is 72. This does get degrees because it's the measure of an angle. It's RQS. And then 3 times 23 plus 14. 3 times 23, going to be 69, plus 14 is 83. And this was the measure of angle TQS. And you can check your work by adding those two together, and sure enough, that does equal 155. And that is all.